So for question two, the way the question is presented show that b hat one is a weighted sum of the observed response. Um, that to me feels like it's asking for a proof that like I need to write out effectively a proof on why that equation is the way it is.
Yes.
Is that the right understanding of the problem?
Yes.
Okay. I don't like that. Okay. I'm not really sure where to get started there. Is there like a portion of the book that you can direct us to? It's like we didn't cover this in class, and it feels like a little bit out of left field.
Yeah, basically it's all algebra. It's all algebra. Yeah, like Professor Bartman write some hints, I think. So that is the right track to start that problem. It's not an overcomplicated problem, I think.
Okay, so it's like the hint is just a matter of plugging in Wi into that formula. And I imagine could I come up with a sample set of data and show that it's a weighted
that's
sum?
not the case, because you cannot like use an example to prove like a mathematical equation. You have to like play with algebra, use the letters only, use the notations, and to prove that equation basically. You do have some formulas, I guess.
Oh, wait, do you want to record this?
I'm recording it, but I don't know. Maybe we can pause it.
Or, no. If you're recording, it's fine. I just didn't see the little record thing. No.
Okay.
That's good. All good.
I don't have that assignment right now.
I can email it to you. Do you want the homework 8?
Oh, maybe I'll try to figure it out. I can download it. Never mind.
Bro, we met Vishnu's cousin there. Oh, that's why you're no, everything. You know, everything is like, it's, I don't know,
oh, yeah, I have it right now. So I think first, we should consider how to calculate the beta 1 using the formula provided in the class. What is beta 1 hat? Right, basically that's the slope of your regression model. Right, your regression is y equals beta 0 plus beta 1 times x. So beta 1 is basically the slope of your regression model. How do you calculate beta 1? Is as follows. Because I know there are a lot of formulas, so to make it more condensed, I created a Word document making all the formulas more concise, and I went over very comprehensive regression analysis, and I have already recorded that video and upload that video to the YouTube channel. You can look at it. And
you did that was a solo video?
Yes. Yes, I think it's like the nearest video in the YouTube channel.
Yeah, no, I'm saying like you just did that on your own, not for office hours.
Yeah, not for office hours.
That's very nice of you. Thank you. Thank you.
Because like in your finals or for like last few assignments, you use the regression models a lot. So
Okay.
this formula, the first formula of the Word document, you see y equals beta 0 plus beta 1x. That is basically the line of best fit of the regression models. The last term is the empty term, and we don't care about it because it has a mean of 0. So basically our formula, our line of best fit is y equals beta 0 plus beta 1x. How do we get predicted beta 1 to predicted beta 0? So whenever we have a hat on a notation, that is our predicted parameter. So beta 1 hat means what is our predicted beta 1. So we are using this formula. That is where we get started, I think, for question 2, because it asks us to
the third formula,
second beta 1 hat.
Hold on, but the third formula, beta 0 hat or beta not hat,
Yeah.
that's just a rearrangement of the first formula.
Yes. Of the first two formula, actually.
No, the first formula, right?
Yeah.
It's quite literally the first formula, except
yes.
Instead of y, it's y bar. Instead of beta, it's beta hat, right?
Yes.
And so like, what is the relationship then between the first and third formulas?
Oh, so the first one is not a formula. It's our line of best fit. I just write it like this. And then I have to calculate the parameters of beta 0 and beta 1 because I have to fit the numbers into the first equation, which is the line of our best fit, right? I have to fit the number of beta 0, beta naught, and beta 1. And the way we calculate beta 1 and beta naught is the second and the third formulas.
Oh, I see what you're saying. So the first formula is a rewrite of y equals mx plus b, right? The traditional like slope formula, right? Where m is b1 and b is b naught, which explains why the formula for the slope b1 or b1x, I guess, is so much more. Virtually B1 is so much more complicated because you're calculating slope rather than intercept, right?
Yeah.
Okay. So the calculation of the slope is like, is that the sum of each value of x minus the average of x times each value of y minus the value of y divided by each value of x minus the average? Okay.
Yes, it's a sum of the product. The numerator is a sum of the product of each residuals of x times each residuals of y.
Okay, and then the denominator is the residual of x squared.
Yes.
Okay, and so the recommendation here is to leverage these components of slope as b1 hat to.
This is how we calculate the b1 hat, and we should we should maybe simplify this equation, this formula, or make some algebraic transformation of this equation, and finally get the equation in the homework. That's how you prove that.
So the goal is to go from the second formula, b1 hat is equal to the sums, the numerator denominator sums, move from there via algebra to b1 hat is equal to the sum of wi and yi.
Yes.
Okay. Okay. I mean, like that's enough. Um,
This
that's
problem
enough.
is
Okay.
I
Thank
think
you.
this is the most difficult problem. Um, and
Yeah. I mean, in general, it's frustrating. Like, I'm not wild about all the theory, right? Like, I'm anxious for practical application.
yeah. So
This is
so
like,
if you look at the hand, it said the
yeah.
weight equals the residual of x divided by SSXX, right?
What is SSXX?
And you know what is SSXX, right?
I don't. Well, maybe I should. I don't.
Okay, so can you see the Word document right now?
Yeah, yeah.
Okay, so okay, this is SSXX. Basically, that is the sum of all the residuals of x. We just come up with some weird notation.
Oh my. Okay. All right.
You see,
It's already
there's like
solved.
some
Okay, I
links
see it.
between those two
I see it.
formulas, right?
I
So
see it.
that's how you
Yeah,
play
yeah.
with
No,
the
I already see
algebra.
it.
Yeah, that's how you play with the
I
algebra.
see it. I see it.
Yeah.
Yep. No, it's clear. Okay. Well, thank you. All right. Number 3. So for number 3, what did I do? So I fit a linear regression model to the data using Minitab.
Yes.
I'm not super sure how to test the hypothesis, but I have an idea and I want to run it by you. Minitab already calculated R squared for me. So are you expecting like more than that?
No, but I expect to calculate manually R squared in the first question. Because the first question you only have 5 observations and it's very easy to do it by hand.
Wait, I don't know. Fuck. I calculated R by hand.
What do you mean you calculated the R?
Oh, I don't know.
Correlation coefficient. So there are 2 things. First is capital R squared. Another one is the little r. So one of them are called coefficient determination of coefficient, and one is called correlation coefficient. But they have a relationship, which is the small r equals the square root of the capital R squared. So basically, whenever you calculate one parameters, you can very easily get another one. So
okay, so
no matter what
can I share my screen?
I expect you to calculate using formulas and by hand for the first question. But for the third question, you can do it using a software, any kind of software.
Can I share my screen? Can I share my screen?
Yeah.
I can't share the whole screen. Oh, yeah, I can. Here it is. Yeah, so this is R, right?
Yes.
Okay, so I misunderstood what I calculated the wrong thing then.
No, you're not calculating the wrong thing.
I thought you said, is little r the correlation coefficient?
I know one of them is correlation coefficient. That is the little r. Yes, the little r is correlation coefficient. And
okay. So then I did do this right. I thought you said I had to calculate.
You did the right thing.
I thought you said I had to calculate R squared in question 1, which we don't have to do.
I mean, yes and no, because I think the better ones that are required to calculate is always more convenient to calculate R squared first. And actually, in statistics analysis, I mean, you learn some tasks later on regression. Most of the time, you're going to use R squared. So
but this is But
It's
so
always
did I
need
just?
to calculate r squared. And this
Did
this little r is just the square root of r squared.
but is this not the formula for r? Or is this the formula for r squared?
I think you are doing the formula for r squared.
Ah.
I'm not too sure. Let's see. A check. Oh, I think you're doing the little r.
I am, right? Yeah, here.
You're
I
doing
did
the
this
little
formula.
r. You're doing the little r, yes.
Man, you're leading me astray, Victor. I can't handle it.
You're doing the little r. That's great. That's great. That's great.
All right. Okay. All right. So then we're good. We're good on question 1. I feel all right. I
Yes.
feel good about it. So, all right. Question 3. I pulled these from Minitab, right? So
Yeah.
you can see here the r squared is presented as a percentage, 17.4%, as opposed to 0.147. But I guess it's all the same.
Yeah.
So that answers. Yeah, here. That's part C. And then part A is graphing it. Part B, I said, is slide 28. I was making a note in class. So what's the question for part B? Test the hypothesis that beta 1 is equal to 0. And I suggested that slide 28 would help me with that. Did I assess that correctly?
Yeah.
So basically I need to calculate the components of this.
Okay, that's great.
Right? So I need to calculate the test statistic. And that should be enough, right? I have all the information I need on the slide.
Yes. So you calculated the t already?
Is that a question or a statement?
It's a question.
I have not calculated the t already.
And you know how to calculate that, right?
Well, I have B1 hat minus D, which I guess is the degrees of freedom.
Now here the D is just 0 because you're gonna test if beta 1 equals 0.
Oh, I see.
Yeah.
And then yeah, I don't know what B1 hat is though.
It's the slope. It's the slope. The Minitab just told you.
That would be 0.02196.
Yeah.
Right? 1.0, yeah. Or blood glucose is X, effectively. Right?
Yes.
If this is Y equals MX, Y equals MX plus B, then my slope is 0.02196. That's B hat. Minus 0 over the, what is that?
This is a standard error of B hat.
Standard error.
Standard error.
Again, that's the.
Oh, you don't have that parameter directly from Minitab. You have to calculate by yourself.
Oh, here.
Just look at the previous slides. Yeah, it has the formula.
Standard error of B hat is SSE over. Okay, I can do that.
You have SSE and you have SSXX. I think maybe Minitab tells you what is the S, but you have to calculate the numeric denominator. I think
it tells me S here.
Yeah, I think that is the S, but you have to do the denominator.
So I have to do the square root of the sum of the difference of the residuals.
Yes.
But I can just do that here, right? Like that's pretty easy. The difference of the residuals from the average of x. So I have to calculate this on my own, right?
Yeah, so if you are using Excel or you're using Minitab, basically you can just manually input your formula and generate the answer.
Oh wait, really? There's a formula for it? What is it?
You're using the Excel, right?
It's Google Sheets, but it should be the same.
Okay, so you should import a formula, right? I don't know what you're gonna input, but you have like square root, right? So like SQRT something, SQRT or
Yeah, but
yeah,
so I need to know the average, right, of x, right?
yeah.
So I could, I mean, I could just break it out. Right? I could just make it more clear and simple.
Definitely.
So I want to know the average of like glucose, which is 10.3, and then I want to know the difference. So I want to know this minus this. Right? It's no, sorry, the other way around. It's the other way around. And then these are all the differences. And then I want to sum them up. And then I want to it's very small. And then I want to.
You have to square it first. Look at the formula of SSXX.
Where is that again?
Yeah, how you calculate SSXX? You find the residual and you should square it.
Oh, it's squaring it, not square root.
And then you have a number, and then you take a square root.
So it's.
So all the numbers should be.
It's the sum of the squares. So I need to take the square. I need to square this, right?
Yeah.
And then we go back down. It's s divided by the square root of that. So hold on. Go back here. It's the square root of the sum of this, right? No. So this is, and we divide this.
Yeah, so I think in the PowerPoint, like Professor had a typo. He didn't square that, right?
2, 1. Hold on. Say it again. You didn't square which one?
Yeah. So yeah, in the slides, right? So there should have been a square notation, right? Taking all the residuals.
Here, right here, right. This should be
up all the residuals squared and then take a square root. I think that is a correct one.
What's that?
Yeah, I think this would be the correct one.
That makes a lot more sense. Okay, that explains why I. Okay.
The t-value.
Victor, do you understand how like remarkably frustrating that is?
What?
Do you understand how frustrating it is to have like typos in the?
I don't understand.
Like if we didn't have these office hours and the rest of the class was referencing
Okay.
Like,
I'll do a review session before final. I promise.
uh, thank you. I am grateful for that.
Did you do the t
Okay,
value?
so we're working on it. So we just figured out the standard error, right, which is B1. Sorry, which is SB1 hat, right? So we have the uh, um, numerator. So we have the denominator of the test statistic, which is right here. So this is SB1 hat. And then we have the M is 0.02196. So we could say, hold on. What is going on? So this is part B. And then we have M is equal to 0.216696. And then in this case, M is equal to B1 half. So we just divide M by, so T is equal to M divided by.
Beta 1 hat is your slope, right?
What?
The beta 1 hat is your slope, right? Oh, you are doing the standard deviation of the beta 1 hat. A standard error, okay. Okay, so you have calculated the denominator. Sure.
This is the denominator, right?
Yeah,
SB1
yeah.
hat.
Yeah, it's a standard
Right?
error of the beta 1 hat. Yeah, it's true.
Yeah.
What's
Right,
your M?
SB1 hat. M is the, oh shit. Sorry, I messed up. M is 0.02196. 0.02196. Yeah, 0.219. Yeah, that's the, my test statistic is 2.11.
And to tell you a good news is if you are really doing the regression analysis using Minitab, the software gives you a t-value automatically.
Where?
I don't know where is that, but you should have it.
So I'll go find it on my own. But you're saying if I plug this information back in, I can ask it for a t-value and it will give me one.
They will not only give you a t-value, but also give you a p-value.
Well, I have p right here.
I don't think that's the that's another p. I think that's another p. If you're doing the f-test, we're not go that further. We're just doing the t-test for beta 1. But I think maybe there is another output.
Okay.
The Minitab. You should find it. And you can check. You can check if that t gives you another value. That means something goes wrong when you calculate that during the office hours.
Yeah, I can check them. I can check on my
own. It
own.
also gives you a p actually. So basically we are doing what exactly like the t-test we are doing several weeks ago. You have your calculated t, and then you go to the table and find the t critical value. Right?
Wait, so what table am I going to for the t? I'm going just to the t table.
Yeah, we're doing a t-test. Remember, whenever our denominator is a standard error, we go to the t table. So here, the degrees of freedom, if you go to a t-table, you have to have two parameters. First parameters is your degrees of freedom. The second parameter is your alpha, or like the percentage that you want to reject the hypothesis. In the regression analysis case, your degrees of freedom equals n minus 2. That is, so in this problem, I guess you have 24 data, observed data, so your degrees of freedom should be 24 minus 2. I'm not too sure, but it's n minus 2. And the alpha is always like the default alpha is 5%. And for the regression analysis, it's always a two-tailed test. So in the t-table, I mean some t-table varies, but maybe you're gonna find instead of 5%, you're gonna find 2.5% for the first parameter. It's alpha divided by 2, and in the vertical line, you find the degrees of freedom equals 22. In the horizontal line, you find the probability is 2.5%, and you can allocate a particular number. That's your T critical number. And you compare your calculated T with the critical number. And again, if your calculated T is greater, then you're gonna reject the null hypothesis.
So why wouldn't I go to 0.05?
So here you're gonna maybe 2.5%. Because it's
Why?
always a two-tailed test. Alpha equals 0.05, right? But that's a two-tailed. So in this table, you find the shaded area is 5%. If you go to that column, the shaded area is 5%. But we are doing a two-tailed test. That means we have two shaded area, one on the right, another one on the left.
And
So
you need them to add up to 5%?
yes, that's the problem. So if you choose the column of 5% and we have two-tailed, then our alpha becomes 10% because that's two tails times 5%
Okay.
each tails. So in this case, in regression analysis case, you always find alpha divided by 2, which is 2.5%.
Okay, I'm not sure I super understand why. In the past, when we had two-tailed tests,
It's
we
very
would
close. It's very close, right? You find 2.07. It's very close to your calculated.
2.07387.
Right, what's your calculated T? It's 2.11. Yeah, it's very close. So if this is the case, you're still gonna reject the null hypothesis because the probability of your null hypothesis being true is less than 5% two-tailed. You're still gonna reject the null hypothesis. Now the only problem is I'm not
So
sure if
one second.
you have the
Like,
correct calculated T.
yeah. We're rejecting the null hypothesis
By the
because.
way, this is not the P. Like the notation, you should have like T critical value. Mostly.
Oh
We
yeah,
say
no.
is
Yeah, no, yeah. I know that.
yeah.
Yeah, that was a mistake. That I know. I was just filling in the table that I made. So because T critical is less than the T calculated value, right? That's why we reject.
Yes.
But if it was 2.4 or whatever, then we would accept it.
Yeah.
Or it's really it's the other way. It's the other way around. It's the other way around. It's because the T calculated value is larger than T critical. If T calculated was smaller than T critical, I know I'm saying the same thing, but I think that's the better way to think about it.
Thing, actually. Yeah.
Yeah. It's just about okay. Okay, I can check those in the tab.
The T and the P. And by the way, if that T is correct, you would get a P value which is smaller than 5%, but not particularly small, because you see like the T value and the T critical value are very close. So maybe you get a P value of like 4.5% something, and that makes sense.
Yeah. Interesting. Okay. That's helpful. We did R squared. What are the residuals? This is the deltas, right, between x and x bar, right? So these. So if I wanted to calculate residuals.
So actually, there is an option when you do the regression analysis in Minitab. There is an option. You can just by checking that option, the software generates the residual graph for you. So by calculating the residuals, you only have like 24 numbers, and it's very hard to make some decisions or conclusions by merely looking at those 24 numbers. One way you can do it is you draw a residual graph, and that's pretty helpful. I will try to I will make another video. I will make another video like going through how to draw the residual graph and how to check normality. Like it says you have to check if that's a normal distribution. And again, we're gonna use a QQ plot. I will go it over by maybe do it this week. Maybe on Thursday or Friday, I will make another video. I'll use an example and make another video. But
What'd you call it? Residuals plot.
yes.
So what's the point of a residuals plot? And again, how are we supposed to know to do a residuals plot? Like, I'm so grateful for your guidance, but like we don't get any in
for this graph.
class.
For this graph, maybe you should, for the second graph, like you just click down the second one. Yes, you would see some problems in the left side, and maybe there's no problem on the right side. Basically, a residual graph, because you have just calculated all the residuals, right? By looking at that 24 numbers, you should find a chaos. If you find like first one is 5, second is 0.5, and some are
What am I
positive, some are negative, you should see a
what am I
chaos.
what am I graphing against though? I'm graphing against the blood glucose, or I'm graphing against the.
I think it's graphing against the mean. Maybe it's a mean. I'm not too sure. But you have something in the middle. Maybe you're graphing against the mean of all residuals. But if you just look at your graph, the right side one is pretty good. Like you just find on Google, the right side one is pretty good because that's basically a chaos. You have some above zero, you have some below zero, and there's no pattern at all. But the left side, you already see some problems because your residuals actually become a straight line, and that is a huge problem. We call it sometimes a heteroscedasticity. It's the longest word I learned. Basically, that means the residual have some problems. Heteroscedasticity. Like the second longest word I learned is homoscedasticity. That is just the opposite of heteroscedasticity.
So the reason that you're saying chaos is good is because if there was grouping of the residuals, it would imply that the residuals are it would actually imply the line does not fit well.
This regression model doesn't hold because when you do a linear regression model and like the first data has a very large negative, the second data has a not that large negative residuals, and like it forms a pattern of a straight line, then that means it's like your former data do not have a linear regression relationship.
What is? I think I'm plotting against the wrong thing. I think I need to plot against short velocity.
will check what you're plotting against because I don't know right now.
I'm surprised you don't know. I don't hear that very often.
I think maybe you are plotting against the mean of your residual. That is just my guess.
I don't think so.
I really don't know, and I cannot like tell you wrong information.
You don't have my vote. Shit. I want to switch the X and the Y axis. How do I do that? What if I... What? What? Aha. Aha. This is the same. I promise. On the left-hand side, it says standardized residuals, right? So this is the delta, negative to positive, right? So if you look at mine, it's the delta, negative to positive, right?
Yes.
And then across the bottom, it is the values that you were seeing before. It's the same values, right?
Yes.
So in this case,
yes.
Oh no! No! Actually, never mind. We're close. It should actually be against the actual X value, so it should be against blood glucose. That's interesting. So you're plotting it against their own values. You're plotting the residuals against the actual value it came from. Interesting. So yeah, okay. Of course, it comes up like this, and then we turn it into a scatter. Wait, this isn't good. That's what this does. That's what this one does here. Predicted versus actual. So like we don't change the x-axis, right?
Yep.
And in this case, we don't change the x-axis. If you look down here, the x-axis is effectively the same. 5 to 20. This is 4 to 22 or whatever. With the residuals.
No, I don't think. No, this is not a right graph. I don't think this is the right graph for residuals.
Yeah, I guess not.
I think maybe I can check what I'm plotting against. Yeah, I'm not too sure right now. I cannot risk saying something wrong and then recording it.
The horizontal axis displays the independent variable. So what is the independent variable in this case? I guess it has to be the short velocity. You hear me? Hello, Victor?
Yeah, I think it's a short velocity.
I think so too. That distribution looked like more correct, right? And so here, this is theoretically chaos.
Yes.
Like more or less, like you have like a reasonable distribution above and below 0, which I imagine what you're looking for, right?
Yes.
So if we wanted to analyze the residuals, we could do that here, and we could be satisfied with the chaos. Is that we're talking about here? We're happy to be chaotic. Is that?
Yes.
That's the outcome.
Yes.
Rejoicing in chaos.
Sometimes.
Okay. So the answer here is like, if it's appropriate, like just in general, right? If it's appropriately chaotic, then we have more confidence. If there are trends in the residuals, then we have less confidence.
Yeah, if it's like a line or a parabola, any kind of trend is not good. We're just looking for chaos.
Okay. and that validates that it validates that a linear regression is the right regression to use
Yes.
for the data set.
Yes.
Okay, I learned a lot. Thank you.
You just have the second problems left over, and I think that would be a very difficult one. I took like a lot of time doing that problem when I was given that problem. So
The problem number 2.
yes,
I mean, I have to rewatch the video, but like I have a loose idea of like this. It's quite clear when you showed me all those formulas. It was quite clear like how they would plug into each other and like how you could get them to work out. Like the algebra like jumped off the page. It felt like, but to be seen if I can replicate
yes,
that vision on my own.
sure.
Okay, I don't have anything else. So I'll let you go.
All right, nice. So good night and see you next time.
Oh, actually, wait, one question. Sorry. The homework was pushed to next week, right?
Yeah,
Why?
I don't know.
Okay.
That's a good
Um,
thing, right?
Well,
Whenever something
there
good
was
happened, normally I don't ask why. For example, if the final was canceled, I think good. I don't ask why.
well, I guess there was concern that the intent of the message was rather to say that there is no homework on next Wednesday because there is no class next Wednesday, not the homework is delayed 1 week. So we want to make sure that like that the intent of the message is truly that it is delayed 1 week rather than canceling homework on the day that there is no class. But I don't want to like I'll take it at face value.
I think you have class next week, but like you didn't like cover
I'm
the SSX
pretty
yet.
sure we don't have class next week.
Really?
I'm like 90% sure.
Okay. Oh.
Wait, are you like
I am not MBA. I'm using like undergraduate calendar, and we have class every day.
Wednesday, November 24th, there are no classes.
Oh my God. Wednesday. Oh, that's good. That's good.
You're scaring me there. So no class.
Okay. Okay. Sure. So
What?
okay. So you have class this week, but not next week.
That's correct.
But why? Like, okay.
So that's why we were concerned that like the announcement was really supposed to be like because you have no class next week, you won't have any homework due next week. That's like, but like we didn't think that would relieve us of the homework. Look, I'm not trying to like turn the homework on a Wednesday. He can't go back on his word now, but we were just confused about.
Okay. So the homework is due on next Wednesday, right?
Right, a day that we don't have class, which I guess is fine.
I don't know. Maybe there's like another due just after that time. I don't know.
Oh, you think we're gonna have double homework on Wednesday?
I don't know, but you have class this week, so maybe you will have another homework after this Wednesday, right? That makes sense, right?
Double homework.
I don't think
Maybe.
that really happens, but yeah, I just try to finish it earlier.
Okay, cool. Well, I think that's it. Thanks again. I really appreciate your help.
Good night.
Bye, Victor.
Some registration work. I'm gonna, yeah, I have to look at my schedule for next semester.
Ooh, fun stuff. Good luck.
All right, bye.
All right, bye.